Okay, so I've already written out the solution for number 5, but let's really chat about it briefly. It's saying describe how you would convert an equation for a plane given in vector form to scalar form. So if we're given a vector that gives us 1 point and 2 direction vectors u and v, if we want to convert it into scalar, we need a point. So we're already given that point, so that's good. And we also need a normal vector. Okay, to find a normal vector, or a vector that's perpendicular to the plane, we can use the cross product. So the way I'd write out a procedure is our first step would be find the normal vector, right? And then we do it by determining u cross v. And when we find the normal vector, that would give us A, B, and C. Okay, A, B, and C are going to be the coefficients of our scalar equation. Right, so then we can write out our equation AB, or AX plus BY plus CZ plus D equals 0. And then once we have that written out, we can take the point that's given in the vector equation and solve for D. Okay, and then we have our equation. Okay, so that would be how we would answer number 5. Okay, for whatever reason, this equation didn't come through in this conversion to PDF, so I've just written it in here, but it says consider this plane 2x minus 3y plus 4 equals 0, and it's saying state a second equation, or an equation of a second plane that is parallel and distinct. Okay, so this just means different, right? Not the same plane. So for it to be parallel, the normal vector, so 2x minus 3y plus 0z, I'm not writing it, has to be the same. Sorry. And then for it to be distinct, I just need to choose a different d value. So this would be parallel and distinct, and really you could choose any d that does not equal 4. Let me make that a bit clearer. So you could choose any d where d does not equal 4. Okay, and then state a direction vector that you know is parallel to the plane. Okay, so to get a direction vector, I have my normal vector. Right? So there's 2 ways I could do this. Right, I have my normal vector here. So if I take the dot product of that vector and any vector, I'll draw 2 examples where the dot product is 90, that direction vector would be in the plane. So one way I could do this is by going 2, negative 3, 0, dotted with an unknown vector, 1k, 0, and set that equal to 0. And then if this vector here, that will be a direction vector as long as this is true. So we're going to have 2 minus 3k equals 0, and so k is going to be 2/3. So one direction vector would be 1, 2/3, 0. Okay, so this would be one possible answer here. The second way you could probably attack this problem is you could just find 2 points. So I could sub in, let x equal 1, and when x is going to be 1, I'm going to have 2 times 1 minus 3y plus 4 equals 0. And then this is going to give me y has to be equal to 2. Okay, so this gives me a point 1, 2. And really z can be anything. It doesn't matter what z is. So let's throw 1 comma 2 comma 1. It's going to be 1 point. And then 1 comma 2 comma 4 is going to be another point. Right? And the reason z can be anything is because the c value is 0. Right? There is no c value, or the c value is 0. So whatever z is, we're going to multiply that by 0. So when I have 2 points on the plane, to find a direction vector, I can just subtract them. So another direction vector that would be parallel to the plane in this case would be 0, 0, and in this case 3. Okay. So that would be another possible answer. Right, and this one is coming from, let's do this in red. Find 2 points. So here we want to go find a point on plane. And here we can say z can be anything. Okay. And let's take this, move it down here. And yeah, sorry. So anyways, this will be your answer, and I'll clear up the written solutions later. Okay. 7 is saying write a scalar equation for a plane that is parallel to the x-axis and y-axis and goes through the point. Okay. So if the plane is parallel to the x-axis and the y-axis, okay, here's our x-axis, here's our y-axis. If our plane is parallel to that, it would be here. And when we think about the normal vector n would be in the z direction. So our normal vector could be 0, 0, 1 would be our normal vector. So that tells us that our equation is going to be 0x plus 0y plus z plus d equals 0. So z plus d equals 0 is our equation. And then we just need to take and sub in our point 1, negative 2, 4. So when we sub that in, we're going to get 4 plus d equals 0. D is equal to negative 4. And then we're going to get z minus 4 equals 0 is our equation. Okay? And that would be the equation for our plane. And then the final question on this page is asking us to determine a vector equation of a line in 2 space that is perpendicular to this line and passes through a given point. Okay, so what we know is that this line that we've drawn here, okay, say this is this line, we know that this vector 3, 2 is perpendicular to that line. Right, this we know from the scalar equation. Right, so we know that from our scalar equation. So what that tells us is that when we want to write our equation, xy is going to be equal to, it's giving us a point, so the point it's giving us we can just sub in as 1, negative 10, and then we need a direction vector. The direction it will be in is 3, 2. Okay? Because we know that is perpendicular to our line that's given to us. Okay, so that's page 3.